force of buoyancy exerted by atmosphere on a balloon is B in the upward direction and remains constant. So suppose we have a balloon and force of buoyancy is B. So buoyancy force acts upward and force of air resistance on the balloon acts opposite to the direction of velocity. So it will act opposite to the direction of velocity and proportional to it. So if balloon is rising upward, the viscous force or friction force will be act downward, and there will be one gravity also acting. So these are the three forces acting on the balloon. Friction force is downward, mg is downward, and the buoyancy is upward. And buoyancy will be what? Buoyancy is acting in upward direction, and all these forces will be balanced because the balloon is rising at constant speed. Force of buoyancy in atmosphere remains constant. Okay, the balloon carries a mass m and it is found to fall down near the Earth's surface with a constant velocity v. How much mass should be removed from the balloon so that it may rise with constant velocity? Okay, so what is the condition? These are the forces given. Initially, the first condition is given. Okay, leave this one. This is just an indicative diagram of forces. First, I am writing the balloon is going down. It is going down. So if it is going down, then one force will be mg, one force will be buoyancy, and since it is going down, one force will be the viscous force, the friction force, and it is fall down with constant velocity. If it is falling with constant velocity, means net force is balanced. So we can write Fv plus B equal to mg. Since it is falling with constant velocity, the forces will be balanced. And its mass is also given. How much? Capital M. Okay, so we will write capital M. Now it says how much mass should be removed from the balloon so that it may rise with constant velocity. So how much mass should be removed so that it will rise with constant velocity? So for rising, if you see rising, the viscous force will start acting in opposite direction. Buoyancy and mg are going to act in the same direction because buoyancy always acts the upward and the weight acts downward. But this time the mass has been removed. So suppose delta m mass has been removed. Delta m is the removed mass. Delta m is removed mass. So the downward force is the downward weight is capital M minus delta mg, and upward is the buoyancy force. Now if it is going up, the viscous force will also act downward, and the viscous force magnitude will be same. Why it will be same? Because it may rise with the constant velocity v. It says it may rise with the same velocity v, and it also says the force of air resistance on the balloon acts opposite to direction of velocity and is proportional to it. So velocity is proportional to the the viscous force is proportional to velocity. So if it is coming down with velocity or going up with velocity v, same velocity, then the value of viscous force will be same. So whatever Fv be acting in upward direction, the same Fv will act in the downward direction here. So what we are going to write is, we will write it like this. We will write the buoyancy force upward and Fv downward plus m minus delta m g downward. So these two things will be there, and we need to find the delta m thing. So we will replace the Fv. Fv is not given in the question. We will replace. So Fv is from here. Fv is capital Mg minus B. So if we put this thing here, we will have B equal to Mg minus B plus capital Mg minus delta Mg. So 2B equal to capital Mg, 2 capital Mg minus delta Mg. So how much is delta M? Delta M we are going to get 2B Mg, 2 Mg. Delta M will be equal to 2 Mg minus 2B divided by g. So this will be the removed mass. This much mass is removed, the balloon will start rising up with same velocity in upward direction.